I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at OptimalPlus with Doug Elder, who's going to talk today about some of the trends that are going on in data. Doug, there are a couple of major things that are going on in data, one of which is the storage of data. Right. The other thing is how we're utilizing the data. Let's start with the storage. How is the storage changing? What's happening now?
Well, I think that what's changing in terms of storage is that we're finding that the more data sources or ingestion points of data that we can connect to, the more and more data that we're creating. So we're needing to find ways to deal with that. And so what a lot of companies are moving towards are data lakes, and they're either doing that on-prem with large, on-premise server systems, or a lot of people are moving to the cloud. Some of our customers have moved to a data lake solution that is on the cloud that allows them to add storage capabilities sort of incrementally in real time as they find that we're collecting more and more information on the operating side.
What is a data lake? How does that differ from what's been done in the past?
Well, a data lake is, if you think about it, just like a lake, and you have all these different streams coming into it. And what it does is it brings all that data in and collectively brings it together. What we're doing from the OptimalPlus side is where, we want to control the type of data that's coming in. What we're doing is that we're actually doing data engineering to the data that's coming into the lake, and we're putting that in a place where we can get to it and run a lot of different types of analytics against the data that we're bringing in for the specific operating requirements that our customers have. It could be fab data, it can be MES data, it can be PLM data. So we're trying to bring all this data together in a single place, which we call a data lake.
Why don't you draw this out for us?
Okay.
So as we get all this data into a consistent form, the other thing that you can do is utilize it differently too, right?
That's correct.
What changes there?
Well, so let's think about it this way. So historically, if I think about a company or their sources of data kind of like a skyline, and you have these different silos of data that are good data and they exist for a purpose and people have collected them for years. But they're all siloed, and so there are all these individual data schemas or sources of data. It could be STDF, it could be ASCII, whatever it might be, and they're all just sitting here. And if you have a problem, you're going to go and take a look at that, and it's going to be individually sort of siloed. But what we see now is the ability to take that and move that into into a data lake. And what we're doing is we are doing data engineering to get this into a sort of an O+ format that allows us to take that data and then start to do some sort of machine learning or data analysis or AI against that data that's now been brought in from these different manufacturing data sources. And again, it could be anything in your manufacturing process, from a front end, sort of your scanner, all the way to end use data that's coming out of a car.
Do you have to change how that data is stored before you can get to this place?
You do definitely need to, and it depends. So you have different types of data. You have warm data, you have real-time data, and then you have cold data. And you want it stored in a way that allows you to get access to that. And so you want to define that up front, whether you want 6 months worth of data, you want 1 year worth of data, whether you want it to go back to 5 years. And so you have different layers of data that you want to use for your analysis purposes. So yes, you do need to sort of define that up front.
This is sort of the same thing you've always done in a compute model, right? Where you have cache, where you have things that you call on immediately, right. And then you also have things that are sitting out in DRAM and then on storage.
And so for us, it's a stack, and you talk about things like Vertica, you talk about Parquet, you talk about maybe Hadoop or the S3 or some different form where it allows you to store that data in different layers that allows you to get access to that data real time.
Does the data still get processed in the same place, or is it processed differently depending upon what kind of data is, how much you need it at any point?
So it typically gets processed in the same place, but you're pulling it into that place. So you have maybe a SQL server that's doing that's massaging or working on the data, or Vertica or some other engine that you're bringing the data into from wherever you have it stored.
How do you define what gets processed where, though, in terms of you may be processing something at the edge or on-prem versus in the cloud?
It's offline versus online. That's the big thing. We have a real-time sort of rules engine that it sends information to the edge. And so for us, we want to have the ability to do stuff inline, real time. There's some things that you may want to do offline and in a batch format. That also is possible. But so you want to define that, and that might be some of the machine learning stuff that you do. You go in here, you pull a bunch of stuff out, you have one of your data scientists go off and do some analysis and write some machine learning algorithms that come out of it. Then you bring that back to the edge, and you pump it into the rules engine, and you now have applied that learning or what you've been able to determine through your machine learning algorithms to your manufacturing process.
And some of this really doesn't even, once you get it all defined and set up and organized, you don't even necessarily touch it with a person, right? Sometimes it's machine to machine.
It's all done, yeah. So for example, I was talking about an adaptive test time tool that we have. And so that is running on its own, adaptively adding and removing tests on a customer's test list. And no one needs to be involved in that. That's being done, real time by the tool.
Let's just walk through this a little bit. So you're collecting data from sensors, which may be on manufacturing equipment. This gets run out into either the edge or the cloud, where it gets processed potentially, or it may be done even closer to that. Then it gets shipped back, but you're also still retaining a piece of that data so that you can analyze it later on, right?
So yeah, that's correct. And so I think the other challenge that you have is if you're like a fabless company, how much data can you really get access to? And so that's one of the big, I think, interesting challenges that some of these companies are facing is how much data can you really get? And at what level is that data? And then what can you do with it? And so I think that, if you're an IDM, you have much more access to your, all the data in your manufacturing process versus maybe a fabless company that's working with a subcon somewhere. Or, in the case of an automotive manufacturer, you may have a third-party supplier that's doing a weldment for you, or that's doing an engine module, a piece of the engine module for you. And so your ability to get that data is only as good as your access to that data. And that's going to be, I think, one of the challenges that's going to be facing some of these companies going forward is, who owns the data and how much of that data can you get access to? So I think that's going to be one of the challenges that some companies are going to be faced with going forward. And then the sharing of that data. Just like the data lake, this can be right here, this could be a semiconductor tier 1 here, tier 1, number 2, and you can start to supply that data across multiple suppliers without giving up any IP. So that's another opportunity that this, these data lakes or this architecture provides.
So where do you see this going? How do you see it playing out over time? Is it just a matter of now we can add more reliability into the pieces? Is it a matter of we can use this stuff competitively? Where does it play?
I think it'll help drive quality. And so if you start to look at maybe autonomous vehicles, or you start to look at, the type of systems that we expect in our homes or our infrastructure today, the quality of those systems, the cost of those systems are going to go down. And I think it's going to allow you to advance faster as well. If you start to look at, again, where you want to go with an autonomous vehicle, and can you ultimately get to a driverless vehicle, the only way you're going to get there is by collecting data during the whole process, end use data, and be able to improve the overall quality of the product, but then the process.
So data will accelerate everything that's going on, right?
I think so, yeah. And as computing power grows and analytics get better and machine learning algorithms get better and they start to evolve, you're going to just see this accelerate.
So how are companies actually thinking about using this data? What do you see changing there?
So I think that if you look at some of the traditional automotive guys or the traditional semi guys, they are still trying to break free of the norms that have historically been a part of their their marketplace and their supply chain and their manufacturing processes. I think that companies that are coming at it differently, just like if you came at a new product with an installed base, it's much harder to come out with a new product that doesn't take into consideration everything in the past. Whereas if you're a startup company, or that you have the ability to come into the market from afresh, I think if you start to think about the use of data as a way to improve your overall performance of your company, the manufacturing process, the quality, the efficiency, the cost, the R&D, in terms of design, how fast can you iterate on designs? I think that those are the companies that are you'll see accelerate in terms of their ability to capture market share and improve their overall product evolution.
So the vertical integration of companies is going to change. Right now, data becomes the glue as opposed to whatever the steps were in the process.
Absolutely right. Your ability to bring all those data sources together and do something with it, I think, will be critical for a company moving forward.
Doug Elder, thanks for a great explanation.
Thank you, Ed, for the time.